All right, so this is Foundation of Math 10. This is section 7.4, solving systems of equations algebraically and using specifically the substitution method. I'm going to highlight this one as the last example. This is part of your assignment, so I'm going to help you with this one. This one looks a little tricky because it's got fractions, right? The coefficients, technically, on these terms are fractions. Now, remember, x over 3 is the same as 1/3 x, right? It's actually a little bit maybe nicer. Oh, is it still frozen? Sorry. It's actually a little bit nicer to show it like this, honestly, x over 3 instead of 1/3 x, because some students are like, oh, where does that x go? On top or on the bottom? Does it have to be on the side? What does that mean? So this is a good way of writing it, and it's totally acceptable. And the thing with fractions is what you want to do is you want to use multiplication. So you want to multiply both sides of the equation by a number that will eliminate the denominators, the numbers on the bottom. And we've done this before. The lowest common multiple between 3 and 2 is what? Anybody know? Yeah, 6. So if I multiplied this equation, that is everything by 6. Okay? I would get this. And I'm going to show this the long way here. Okay? You don't have to write this out exactly if you want. We'll just watch this. That's fine. But look at this. I'm going to write 6 times each one of these terms, because that's what this really means. So 6 divided by 3, you can do that first, which is what? 2 times x. So that becomes 2x. 6 divided by 2 is 3. So that becomes minus 3 times y. Sorry? Yeah. Yeah. Okay. Whatever. Minus negative 6 over 2 or minus the 6 over 2. That's all the same. And then 6 times 2 is 12. So this equation right here looks very different from this one, but they are the same line. It's just a different form. Okay? Now I could graph those two. I won't take the time to do that right now. You could graph the two, and you'll see that they're the same line, and then you know you've done that correctly. Okay, so I'm gonna leave that one. Okay. Oh, I'll put that 6 back there. Okay. Now, what do I need to multiply the second one by to get rid of all of the denominators?
12.
Ah, thank you. 12. You could multiply by 6 times 4, or 24, but that's not the lowest common multiple. That's going to give you bigger numbers than you need. Okay? To simplify that equation, you would have to divide all those numbers again later. So yeah, the lowest common multiple is 12. 6 goes into 12 2 times. 4 goes into 12 3 times. So let's do that. Let's multiply by 12 and see what we get. 12 over 6 is 2. So 2 times whatever I have up here is 2 times 5x is 10x. Awesome. 12 divided by 4 is 3 times 3y is 9y. Okay. And then 12 times 1 is 12. Okay. Okay. Interesting. So this question, I didn't even read the question, but identify a number you could multiply each term by to ensure that the equation has only integer coefficients and constants. That's what we've done. Explain why you chose that number. Create an equivalent linear system. Okay. So this doesn't actually ask us to solve the system at all. It just asks us to create an equivalent linear system. So right now, what we've done is multiplied the first one by 6, the second one by 12, and then we've created another system that should be equivalent. Okay. Verify that both linear systems in part A have the same solution. Okay. So now here's where we go ahead and we're going to substitute. Now we're going to solve for one of these systems. It could be easier to solve for the second system here. Okay. It could be easier to solve for the second system. Now I have a question for you. This situation right here, both of these expressions here and here, both of them equal 12. So, using the transitive property that we talked about before, would it be a good idea for me to make one equation by letting 2x minus 3y equal 10x plus 9y? Because they're both equal to the same thing. Could I do that?
Yeah.
I could. Is that a good idea? Let me just write it out for you real quick. 2x minus 3y equals 10x plus 9y. Now, is that a good equation for us to try and solve for a variable? The problem is what? We have now one equation, but we have still two variables. So this is not a good idea because I want one equation. Remember, I want, where did I write it down here? I want one equation with one variable. So you might have noticed that they both equal 12, and that is true that these do equal each other, but that's not going to help us solve for one of those variables. So we're not going to do that. Okay? Instead, what we're going to want to do is we're going to want to try to solve for one of the variables and then substitute in. And I think we may have a fraction situation here. So we got to learn to deal with fractions. That's okay. So I need to solve for one of these variables. Like the 2x here, I could solve for x maybe and then substitute that. And I could solve for y. Usually it's a good idea to solve for y, but you don't always have to. You don't always have to. Let's solve for y, because usually solving for y is a good idea. So I'm going to solve for y in the first one. So the first equation says negative 3y. I'm going to go 12 minus 2x on the other side. I'm going to divide everything by negative 3. So that means I'm going to get y equals, what's 12 divided by negative 3? Thanks. So 12 divided by negative 3 is going to be negative 4, right? This is going to be plus 2x over 3, or 2/3 x. So we can't get away from fractions totally, but I am going to now substitute this into my second equation. So this first equation is now turned into this one. Everybody see that? I'm going to bring this up here because what I want to show you is that y equals this right here. And so I'm going to put this in for the y in the second equation. And then I'm going to have no more y's. I'm just going to have x's. And I'll be able to solve for an x. So this is an upper level one here because we got fractions involved and so on. But this is what it's going to look like now. So I'll write it in black, just like this second equation. So 10x plus 9 times, look at this, negative 4 plus 2x over 3 equals 12. Is everyone okay with that? You understand that?
Yep.
Yes? Any questions about this, what I've done so far in that because that's really important, that substitution part's really important. Okay? All right, I have one equation, I have one variable. Perfect. Now I'm going to expand this, and I'm going to get rid of the brackets, and then you'll see that this will also get rid of, look at this, it'll also get rid of the fraction here, because 9 over 3, okay, is just 3. So this is going to be 10x, I'm going to leave that alone. This is going to be minus, what's 4 times 9? 36. This is now going to be plus 9 over 3 is 3. So 3 times 2 is 6x equals 12. Awesome, I don't have any more fractions, great. So I'm going to combine like terms. I've got 16x over here, right, when I do these two. And I'm going to add 36 to both sides. Equals, what's that going to be? 48. So if I divide by 16, what's 48 divided by 16?
3.
Exactly 3. Very good. So that's one piece of my puzzle here. And I am going to use that, x equals 3, in either one of the equations to solve for y. I already have y isolated here. So I could probably use that one. If I've done every step correctly, I could go back and use this one. This is the equation that I manipulated, so might be a good idea to try the other one. Just because if I made a mistake here, it might show, I might get the wrong answer if I've made a mistake earlier. So this one has been relatively untouched. One of these original equations would be good to use too. But this one here, I'm going to put x equals 3 into the second equation. So 10 times 3 plus 9y equals 12. That's 30 plus 9y equals 12. That's 9y equals, what's 12 minus 30 is negative 18. So y is negative 2. Okay. Hopefully I didn't do that too fast. Now, does that look good to you guys? Y equals negative 2, x equals 3. Yep. So x and y, that fits in this one too, those values. All right, verify that both linear systems have, in part A, have the same solution. Okay, so that part here, and I'll do that real quickly, but I would have to now go back to the original equations before I multiplied them out and changed them around, and I would plug in my values of 3 and negative 2, and I would make sure that those values work in both of those equations. Okay, so quickly that will look like this. So do a quick check. Yeah, then everything seems to work out here. So I've put in the values and checked for both of them. They both check out. So my solutions are x equals 3 and y equals negative 2. Those are the only two things that are kind of circled or highlighted in my answer. Those are the solutions, and here's the verification. All right, so if you've done that, you've done a third of your assignment really with me. So hopefully you have that, you've been following along. Any questions about it? So solving this system algebraically, right here with the fractions in it, that's probably the toughest ones you're going to have to do. You'll have ones with decimals. You'll have ones with decimals maybe, and if you do, you have to multiply by 10 or by 100 or by 1,000 to get rid of the decimals. You understand? So just move the decimal place over by multiplying each term. So you might come across that again. Right, you guys ready for your assignment then? Everybody's feeling good?